I'm Mark Sponsler, and welcome to the Stormsurf video surf forecast for the week starting Sunday, June 7th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we don't see a whole lot going on at the moment. A tiny gale southeast of New Zealand is producing 34-foot seas over a tiny area aimed mainly southeast at Antarctic ice and doing nothing to generate swell. All right, let's get into the details. As usual, we'll start off looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough that is a pushing the jet to the north, and we don't see it, except here in the far southeast Pacific, just south of Chile, but that's well out of our forecast area's swell window. What we do see is a split jet stream over the New Zealand area, no troughs. Well, maybe that you could call that a trough, but not enough wind energy to mean anything. And then the jets, the two branches of the jet, the northern branch and the southern branch, actually merge over the southeast Pacific, but they start falling hard to the south. This is called a ridge. This does nothing to support gale development. If anything, it suppresses it. So for now, a pretty placid pattern is indicated. We'll start putting this in motion. This pattern basically holds till we get into maybe Wednesday or so, and we get a push of energy pushing under New Zealand here, with the jet lifting up to about 52 south, but no clear defined troughs indicated until you get into, here we go, starting into Thursday, a little bit of energy, wind energy, start pushing to the north, and that's what you want. That helps develop a clockwise circulation aloft and down at the ocean surface, and that is the hallmark of low pressure. And low pressure, it's deep enough, strong enough, helps generate wind. Wind generates seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, of course, turns into surf. So we get a bit of a trough starting developing late Thursday night with 130 knot winds pushing up into it, offering support for gale development. Look at this, actually pushing almost due north as we get later into Friday, carving out a decent trough. It's a little bit tight, a little bit pinched as we get into Saturday, but then digging out even better, pushing well to the north up to about 44 south on Saturday, and continuing, then starting to pinch off as we get into Sunday, and we're almost at 180 hours. Then whatever support for gale development should end at that point in time with a big ridge pushing south over the southwest Pacific, but still a bit of a trough here in the far southeast Pacific. Not sure if anything will materialize from that, and it's still a week out. But it looks like there's some hope in the upper levels of the atmosphere. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, 1030 millibar high right here, kind of pushing to the south a little bit. Here's a little gale. What's the ice line? It's around 65 south. Here's that little gale here with southeast of New Zealand with 40 knot east winds generating some seas, but of no real consequence. The same deal with this guy here. Now look at this. Oh, moving into Sunday night and into Monday. Fetch, decent sized fetch, but pretty much out. The Southern California swell window ends at about 117 west, something like that. So this, for the most part, this fetch here looks aimed more at Peru and Chile than California. Continuing into Monday night, little gale develops southeast of New Zealand. Let's see if it does anything. 45 knot winds, sort of pushing to the north a little bit, maybe some hope. We know that there's a trough forecast in this area. Oh, and a secondary gale right behind that with 45 knot winds on Tuesday. And so somewhere in this area, perhaps some support for gale and therefore swell development, but nothing too particular, nothing too exciting to look at. We get into Thursday. We know there's a trough that's supposed to start building in this area as we get into Friday, and there we go. 40, almost 50 knot winds over a tiny area. Broad area 35 to 40 knot winds lifting or pushing northeast, continuing through Friday night into Saturday, looking much better at that point in time. 35, 40 knot winds with a core here to 45, almost 50 knots, and better as we get into Saturday. There we are. Decent sized fetch, pushing well to the north. In the West Pacific, perhaps, if this forms, some decent swell could result. And that continues even as we get into Sunday with 45 to 50 knot winds aimed due north. Certainly, if this were to materialize, Tahiti would see some solid swell, and likely Hawaii, and of course the U.S. West Coast. And it continues on even into Sunday night, fading a little bit Monday. High pressure at that time developing east of New Zealand, likely pushing the storm track south. All right, let's go take a look and see what effect those winds are going to have on the ocean surface. But before we do that, a gale. We're going back Sunday a week ago. A gale pushed under New Zealand. I think seas were up in the 38, 40-foot range. Continued east, 43-foot seas as of 6Z Sunday, and then it started fading while gently lifting northeast. Swell from this system is hitting Hawaii now. The very faint signs of it are starting to show on the buoys in California with period like out at 22 seconds. This swell will hit during the work week and make for some rideable waves, but the point being, it didn't lift well to the northeast, not like what that system that's forecast out, Friday, about a week from now, a little less than a week. This one was pretty much tracking west to east, and so it's more sideband energy that radiates up to the northeast. But when you get a gale that pushes well northeast or almost due north, it's pretty astounding how much more swell energy arrives in Hawaii and California as compared to the more west-east traveling gales. Anyway, so that was as of Sunday. Monday, this gale faded out, and as we said, that swell is starting to build. Another small gale developed on the far southeast Pacific on Wednesday. I mean, we're talking a little tiny area, 32-foot seas, sort of faded, then rebuilt with 31-foot seas lifting north out and east. Most energy, of course, aimed at Peru and Chile, but real south-angled swell from this is expected into Southern California midweek or so, and even up into Northern California. We'll see how much really materialized. We'll go through the models here, play the rest of the animation. You see, really nothing else happened. Now let's go take a look at the forecast. So here we go. Sunday night, not a whole lot going on. A little gale develops here on, we'll call it late Monday night, early Tuesday, with 34-foot seas, but over a tiny area. A secondary gale behind that, stronger with 42-foot seas, pushing under New Zealand. This is actually an upgrade from the previous couple of runs of the models. 37-foot seas pushing under New Zealand on Tuesday. So that's the 10th. So maybe about 9-10 days later, some swell up into California, about a week for Hawaii. But again, this is one of those moving west to east, not large in fetch area, no northward projection to it, so background swell at best. Now we know as we get into Friday, a new gale is forecast developing. Here we go, southeast of New Zealand, lifting north with 32-foot seas over a pretty good area, building to 35 feet as we get into Saturday, 37 feet, and then holding 37 feet into Saturday night, and even bigger, nearly 40 feet on Sunday. Now, this is a week from now, and still, and holding into, Sunday night at least. So, if that were to materialize, some decent, solid swell should radiate into Tahiti, Hawaii, and California, and of course, South and Central America. But it's still a bit out on the models, almost a week away, so we're not going to hold our breath right now. Now, another thing, we're looking at Windswell, and we will say, relative to California, at least north of Point Conception, north winds have just been non-stop, just nuking, it seems like. High pressure, in control, blowing firmly. It doesn't look nearly as bad on the models as what it seems like on the coast. Hawaii, not seeing so much of it. And then, so we get into Monday, more of the same deal. Northwest Windswell. Notice low pressure here in the Gulf of Alaska, sort of cutting the legs out of the high relative to Hawaii. Still, windswell likely for California Monday. We get into Tuesday, continues the high, pushes in, the low pressure system starts pushing inland, sort of tries to knock the high down a little bit, but not too much. Tuesday night, still north winds along California, trades into Hawaii, 15 knots, making for, some form of, junky rideable east wind swell along east-facing shores. The gradient fades a little bit Wednesday evening into Thursday. Let's see if it comes back. Trades, though, look at this, solid as we get into Thursday for Hawaii. 20 knots, definitely wind swell to result from that. And then you notice this high, 1038 is that 1038? No, 1030 millibar. Sorry. Here, we'll click away from it for a second. There we go. 1030 millibar. Yes, still pretty solid. And it likely, there it goes, working its way into California Friday night, Saturday. North winds continue. Look at this broad fetch of east winds as we get into Saturday for Hawaii. That should certainly generate wind swell for east-facing shores of the Hawaiian Islands. Trades, strong. Not trades. North winds, pretty strong Central California again as we get into Saturday night. Sunday, look at this, 25 knot north winds along the entire California coast a week from now. And solid trades pushing into Hawaii. Lots of wind swell in the picture. If there is ground swell, you got to find some protected corner somewhere to try to catch it without it being completely destroyed by the wind swell. That seems to be the name of the game lately. Whenever we get some sort of long period ground swell from the south, the trade wind swell either blows it out completely, or if you find some protected south break, still warble from it, interferes and sort of breaks up. Maybe that's good in some places, but in most cases it just makes for a mess for the southern hemi swell. All right, moving on. Let's go take a look long term. Let's see what's going on with the MJO, the Madden-Julian Oscillation, a periodic weather oscillation that traverses from west to east across the equatorial Pacific. When in the active phase, it helps feed energy in the jet stream and supports storm production. When in the inactive phase, it basically does the opposite. Supports high pressure development and sort of stomps on storm development. And then, of course, let's go take a look. Are we moving towards El Niño or La Niña? I think we all know, but we'll dig into it. So first off, we start looking at the MJO, looking for the presence of the active or inactive phase of the MJO. We look at winds on the equator. This is data from the TAO buoy array, a series of buoys strung across the Pacific on the equator, used for monitoring El Niño, but are pretty good for also monitoring the state of the MJO. All right, this is the East Pacific here, West Pacific here. That is the equator. The date line, 180 west right there. That's New Guinea there. We're just looking at the arrows. Winds pretty solidly out of the east in the East Pacific, Central Pacific. Then we get into this area, it's the West Pacific, we call the Kelvin wave generation area, because if you have the active phase of the MJO over this portion of the equatorial Pacific, and if the active phase is strong enough, it will take the trade winds and reverse them, or at least dampen them considerably, allowing warm water that's typically here to start sloshing to the east. If you get enough active phases of the MJO back to back and they're strong enough, that can help kick off El Niño. So looking at trades here in the Kelvin wave generation area, they're still out of the east, not super strong, but not particularly indicative of the active phase of the MJO. But is the anomalies, differences from normal for this time of year, it really tells you, sort of puts you in historical perspective. So we see strong east winds here, but anomaly-wise, we're not seeing, we're seeing maybe a little arrow there, arrow there from the east, but in general, pretty much normal trades. Same thing over the Central Pacific. When you get into the Kelvin wave generation, maybe even a little bit weaker, maybe some faint hint of the active phase of the MJO, but mostly neutral. Nothing too much to look at here. So let's go look at the forecast for the next 7 days. This chart, the whole planet on one chart. All right, the far west Pacific starts at about 135 east, like right there. The far east Pacific at about 80 west, right there. This is equatorial Pacific, so consider that like Ecuador. Kelvin wave generation area from there to about there. And here's where we are today. So The yellows, reds are westerly anomalies, maybe suggestive of the active phase of the MJO, but tomorrow we're supposed to start getting easterly anomalies developing and pretty strong and solid, filling the Kelvin wave generation area for the next week, probably indicative of the inactive phase of the MJO. And if you kind of just look in this area over the past month, strong inactive phase. If this was the active phase, it's very weak. And then here we go with another fairly strong inactive phase. That sort of pattern when you get the inactive phase is strong and the active phase is very weak is typically how La Niña develops. Let's go look out 2 weeks now, and what we're looking at here is not east or west anomalies of the wind, but cloud cover. That is outgoing long-wave radiation, sunlight reflectivity off the ocean surface. The yellows mean more sunlight reflectivity, means high pressure, means the inactive phase of the MJO. This per the statistic model, and it basically suggests, and the Kelvin wave generation area is right there. So this suggests inactive phase, 5 days from now, inactive phase, 10 days from now, inactive phase, 15 days, 2 weeks from now, inactive phase of the MJO. That per the statistic model. The dynamic model, basically saying exactly the same thing, suggesting we are moving, if not in the inactive phase, and it's supposed to hold for at least the next 2 weeks. Next, we look at phase diagram charts. This is a fancy way of being able to see exactly where the active phase of the MJO is. So assume this circle is the North Pole. We're looking down on it from above, down on the North Pole, and the MJO rotates or moves from west to east around the equator of our planet, from the Indian Ocean over the maritime continent, that's like Bali, over the West Pacific, East Pacific, under the United States, across the Gulf of Mexico, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot right there is where the active phase is, so we'll say over North Africa somewhere, something like that. And the further the dot is away from the circle, the stronger the active phase is. So a very weak active phase. The inactive phase is on the other side of the planet, so roughly here, somewhere between the maritime continent and the West Pacific, and that pretty much trues up with everything we're seeing so far. That makes sense. And the forecast is right here. These three little lines, they're all suggesting the active phase basically falling apart somewhere over the Indian Ocean and hanging there for the next 2 weeks. That per the statistic model. The dynamic model suggesting exactly the same thing. No big surprise. We'll look at an upper level model now. This shows you the potential for rainfall, but basically links with the MJO. The oranges and yellows, dry conditions, no rainfall, typically the inactive phase of the MJO. We see that as of today, and this runs about a week ahead of what happens down at the surface. Inactive phase in control, not pushing over Central America and out of the Pacific till June 27th, it looks like. So pretty much the whole month dominated by the inactive phase. Then the active phase shows up pretty weak, making its move across the Pacific late June, pushing into not even completely through Central America till July. So July looks like the opportunity for storm development, and then the inactive phase developing behind that. We'll take a look at the CFS model. This goes out 1 month. Again, the whole planet on one chart. Kelvin wave generation area starts right about here, West Pacific, and goes to about right here. And this again, now this is the east and west component of the winds. You see the oranges and yellows are westerly winds right in here. But a day from now, easterly anomalies start building, and they continue, if anything, getting larger, filling the Kelvin wave generation area a month from now. See this purple dotted line right there? That is the low-pass filter. And it suggests a high-pressure bias building in the Kelvin wave generation area, another sign or symptom of a developing La Niña type situation. And then finally, the 3-month CFS model, 850 millibar zonal wind anomalies. That's the winds up about, the east-west component of the wind up about 4,700 feet, which is a pretty good proxy for what's going on down at the surface. Right, past performance is on the bottom, the forecast is up here. Kelvin wave generation area going from here, the whole way up the chart, to about, right about there, something like that. Now, in the past, you see these balls of, or pockets of yellow-orange anomalies. That's westerly winds. That was the last really good active phase of the MJO we had back in late February. Since then, it's been kind of a mixed bag, and you see the blues, that's easterly wind anomalies. Here we are today, and looking forward for the next 3 months, we see nothing. And in fact, you see easterly anomalies that were like, this is the Indian Ocean over here. They start migrating to the east and then just take root in the Pacific starting, about June 23rd, we'll say, and just solid in control out into September. Let's overlay the MJO. Now, this is interesting. So, okay, here's our some sort of a weak active phase. It's all but gone. We think the inactive phase is already in control, or will be as of tomorrow. And that's forecast to hold, and you see easterly anomalies. It's typical for easterly anomalies to develop during the inactive phase of the MJO. But then you get a pretty robust active phase that's forecast to start in the Kelvin wave generation area, starting, we'll say mid-July, something like that. And yes, you get westerly anomalies, but still easterly anomalies in the core of the Kelvin wave generation area. And then an inactive phase comes in and totally just fills the Pacific with easterly anomalies. The whole way California, right here is like Ecuador, right? You see easterly anomalies from Ecuador the whole way back to as far west in the equatorial Pacific as you can go. This, again, smells very much like La Niña. Let's overlay the low-pass filter here. And sure enough, all right, so last year, this solid line here, low-pressure bias in the Pacific. We thought we were in like kind of some sort of weak El Niño. We weren't, but the atmosphere was kind of acting like that. But notice we get the dotted contour, two of them, as a matter of fact, suggesting the development of La Niña, high pressure bias in the Pacific taking over, while the low pressure that was in the Pacific last year starts building in the Indian Ocean. This suggests that all the storm activity, swell production will be in the Indian Ocean or the southern Atlantic even. As we get into August, September timeframe, and that the North Pacific will have a much harder time developing sustained storm cycles. All right, so enough of the MJO. Let's start digging into the El Niño, La Niña question, and we start by looking at subsurface ocean temperatures. Again, data from the TAO buoy array, the buoys strung across the equator, and we're looking at temperatures under the equator. This is the far west Pacific here. This is the far east Pacific here. These are the anchor lines on the TAO buoys. The X's are the sensors on those anchor lines. They pick up temperature data at different depths, 100 meters, 200 meters, 300 meters down in the ocean. And then that data is integrated with a model to fill in all the gaps, and you get a profile of the surface temperatures. During La Niña, typically, you have warm water all balled up in the far west Pacific and a cool regime in the east Pacific with a steep thermocline. That means warm water here and then getting progressively less as you move to the east. During El Niño, this warm water starts sloshing off to the east. You get a flatter thermocline. All right, so just eyeballing this right off the bat, you see a 30-degree isotherm right here. It's 30 centigrade at about 155 east. That's even smaller area than it was last week. Now, the 29-degree isotherm, I think it was at 180. It's actually sloshing to the east a little bit for the moment. The 28-degree isotherm also, it was right around 160. Earlier this week, it made it almost to 150. It's backtracking a little bit now. But the 24-degree isotherm, it was working itself it has been for months, a year now, the whole way into Ecuador. Not anymore. Makes it to a point 120 west, that's south of California, and that's it. So this suggests cooler water building in the Pacific, typical of like a La Niña sort of pattern. But this isn't absolute. You want to look at how do these temperatures compare to normal for this time of year? Well, we see that too. No big surprise. Now, the good news is, well, let's start here. Warm water, very limited, only 1 degree above normal. In the far west Pacific, neutral to about, what is that? 150 west. We'll say a point south of Hawaii on the equator. Now, cool water, still minus 3 degrees below normal, but not as cold and expansive as it was last week or the week before that, but still gurgling to the surface, filling the East Pacific. No big surprise there. Another model using the exact same data paints basically the same picture. Cool water, 1, 2, 3, 4, 5, 6. What is that? 1, 2, 3, 4, 5. Up to 5 or 6 degrees below normal here in little pockets. That's pretty cold water. So taking over the East Pacific. Now, the interesting thing is a couple days ago, that cool water was like not only there, it was dribbling out of the maritime continent and connecting, filling in, but now the past day or so, we're seeing warm water building in the far west Pacific, sort of chopping off the cold flow. Don't know that really means anything, but something to keep our eyes on. Sea level anomalies, just another way to confirm what's going on at depth of the ocean surface. This is JSON-2 satellite data. You strip out the wave heights, you strip out the wind waves, strip out the tide, and you get to see whether the ocean surface is higher or lower than normal. We see clearly, so let's get oriented here. Mexico, Central America, Peru, Chile down there. There's your equator, there's your date line. Clearly, this whole area right here, down into here, 10 centimeters below normal. What that means is cold water at depth is in control. Cold water sort of contracts, and when it contracts, it makes a little divot on the ocean surface. And this is just saying cold water is basically in this entire area. That is very much a La Niña type signature. No warm water anywhere till you get to 160 east. That's way far in the east. Now, last week or the week before, we kind of had a horseshoe pattern here, which sort of suggested cold water was just like put not only here, but pushing from east to west to the West Pacific, cutting into the heart of whatever warm water was here. Now, even the warm water that was in the northern branch of that horseshoe is gone. Still there in the southern branch, though. So, basically, this just confirms what we were seeing in the other charts. So this sort of shows you the pattern of the trend over the past year. This is the West Pacific here, East Pacific here. The yellows and oranges are warmer than normal temperatures. Basically, Kelvin waves migrating from the east. Last summer, we had 2 Kelvin waves. They stalled, very weak. Then we finally got a stronger Kelvin wave. It took warm water, pushed it off the east, made it the whole way to Ecuador in the December timeframe. Another one sort of half-heartedly tried to make it, never hardly really made it to Ecuador, and then in April, it died too. And then here is the emergence of this cool pool. It tried to do it last summer, didn't really do it, but that in and of itself pretty much cut the momentum out of the jet stream of any storm development, even though it kind of looked like El Niño on some of the models was trying to organize, and with the low pressure bias right in this area over the dateline region, it just killed the jet stream, and last winter was pretty much a non-event. And now we've got the same thing going on, only stronger this year. We did not get La Niña last year, but this might suggest that we do. And with not piles of warm water building up anywhere, I mean, we think the warm water in the Pacific is pretty much discharged. We think we're moving towards a La Niña pattern, and this only helps add fuel to that fire. All right, let's go take a look at ocean surface temperatures, okay? Pretty obvious pattern going on here. The yellows and oranges are warm water, or warmer than normal. The blues, cooler than normal. There is Ecuador right there, Central America, Mexico, the Galapagos right there. So this is all stitched together. There's not 2 of these, there's only 1, but you get the general idea here. Now, what's been happening this week? Well, we see cool water. There was sort of a pocket over the Galapagos, a pocket off of Ecuador, but they weren't connected. Now they are. There was pretty good warm water off of Peru from that last year's previous El Niño-like thing that was going on. That's all quickly dissipating. Cool water starting to build. So this all clear, and the cool water goes the whole way almost to 160 west. So this smells very much like strong easterly anomalies, like the inactive phase of the MJO has been in control for months now. Upwelling, the cool pocket underneath the Pacific equatorial region, upwelling to the surface. Strong trades. Another sign of strong trades, nuking north winds in California, because it's all driven by high pressure off the California coast. That makes the north winds along California, but it also drives the trades here, which causes the upwelling. High pressure also in the South Pacific, rotating the other way, counterclockwise, doing the same thing, creating upwelling here. And, if you have high pressure here nuking, high pressure here nuking, stronger than normal in both cases, it just starts feeding the trades on the equator, creating massive upwelling, and there's no way you're going to get a Kelvin wave. There's no way the active phase of the MJO is going to do anything. The balance of the atmosphere appears now to be towards cooling in the Pacific, as the engine for the active phase of the MJO and anything that would drive El Niño is moving to the Indian Ocean, because that's where the low pressure bias is. The 7-day trend, ocean temperature trend, again, the same pattern. You can see it. The blues are cooler than normal, or cooling. Cooling trend off of Peru, Ecuador, the Galapagos, on out to, well, there's Hawaii there. It doesn't make it as far as south of Hawaii, but this all smells like the inactive phase of the MJO, pretty much in control, driving trades, causing significant upwelling. And then the backed off view, again, more of the same. Cool water off of Peru developing. This is the early signs of La Niña. Typically, in a mature La Niña, you'll see cool water sort of working its way up into Central America, down into South America, in a big kind of a triangle pattern here. The exact opposite of El Niño, where it'd be warm water here. It's early in the year. It's only June. We wouldn't expect this to peak out until Thanksgiving, December, probably earlier December sort of time frame. So this is pretty much right on track as compared to the last La Niña that happened, what was it, in 2016-17? So, and that one was moderate. Maybe, hope if we're lucky, this one will end up being moderate, not too strong, but we'll see. What is the sea surface temperature trend in absolute values? Niño 1.2 index, this is the area, the Niño 1.2 area, right there along Ecuador, Peru, and the far east, the far equatorial east Pacific. You can just see the temperature trend. This is in centigrade, but we were up at 0.9 above normal back in March. Steadily downward today, minus 0.888. Over 3/4 of a degree, almost 1 degree below normal. And you can see it's just steadily pulsing downward with each pulse of the inactive phase of the MJO. And then the Niño 3.4 index. This is the official El Niño/La Niña monitoring region. It too, last in March, April, pretty warm, like in minimal El Niño territory, about 0.5 degree above normal. Today, yes, it's only minus 0.211, 0.2 of a degree below normal, but it was down at -6, and it looks, especially when you look at what's going on here in the Niño 1.2 region, we expect this one to continue to dive down too, on a steady downward trend. One other El Niño, La Niña indicator is the Southern Oscillation Index. This is a measure of the atmosphere, okay? We've talked about what's going on in the ocean at depth, at the ocean surface. Now we're going to take a look above the ocean and what does the atmosphere think is happening. So it's the difference in pressure between Darwin, Australia, and Tahiti. When you have low pressure in the Pacific, the index goes negative. Today we're at minus 13.71. You go, hey, well, that's not too bad. I mean, if you have that over a long period of time, then that's we're talking 2 weeks, 3 weeks. That's a sign of the active phase of the MJO, right? And if it goes on for a long period of time, like 90 days or more, then maybe you're moving towards El Niño. All right, so today we're at minus 13.71. Not bad. And you look back the past couple of days, go, wow, look at this, minus 46. That's fairly impressive. But it's only 5 days like that. Prior to that, it was positive. And you go down here and look, and it's been pretty positive. And then you start digging, looking at the models, you see there's been tropical low pressure over Tahiti the past couple of days. So no wonder the index is negative. As soon as that low pressure moves out, boom, this will be back positive. 30-day average, minus 1.99. Basically neutral, and we were above. We were at 2.85, but the low pressure again has dropped the 30-day average down some. It'll probably go even a little bit deeper before it starts to rebound. You can see where we've been. We've been at +1 to +2 pretty much nonstop for a month now. 90-day average minus 2.8, still not even neutral yet. And have we been neutral? No, we haven't. You see, past month we've been negative, but we suspect this too is going to start creeping towards the at least neutral, if not positive territory. To be La Niña, though, you need to be at +12, +15, something like that. We're a long ways from that, so we'll see where we end up. But as of right now, we are certainly nowhere near El Niño. And then finally, the official sea surface temperature forecast for the Niño 3.4 region, the official El Niño monitoring region. That's the area on the equator south of California from 120 west to out almost to the date line, 170 west, 2 degrees north and south of the equator. When this is positive, that means temperatures are warmer than normal, and that's, if it's more than half a degree above normal for 5 consecutive 3-month periods, then you're into El Niño territory. And that's kind of where we were last winter. You can see that here. But now, in April, the index, or the actual temperatures started falling. Here is the forecast. The dotted line is the forecast. When we get into July, we're supposed to be down to 0.55, half a degree below normal, sort of hanging there through summer, and then creeping even lower to 3/4 of a degree below normal in October, and then when you get into the critical December time period, almost 1 degree, let's say 0.95 a degree below normal. That's clearly La Niña territory. Half a degree for 5 consecutive months would be up here. Maybe this is overhyping it a little bit. Some of the other models are not, they're saying more of a neutral temperature, but this model we think is pretty much on the money for right now, suggesting the development of La Niña for the coming fall. So the good news is that there is swell in the water pushing towards California. That swell is already hitting Hawaii, not particularly large, but mainly because, again, that east-west track or the west-east track of the storm didn't really angle at Hawaii. California do a little bit better, nothing huge, but rideable surf through the week. And now the models are looking a bit better with perhaps a solid gale pushing well to the north in the central South Pacific over the starting about 5 days from now. So maybe some swell from that. And there's even a small, actually kind of a moderate-sized, very south-angled swell that's in the water that's going to arrive midweek as well. So there's surf to be had. Now, the not-so-good news, the long term, is it looks like we're moving towards La Niña. All the indicators suggest it. Cool water, I won't go through it all, but you kind of get the picture. But the flip side of that is that does not mean that there won't be surf. Okay, it just means that the probability for massive storms that last long, that produce large swells that last a long time, probably not as high. It'll be more like hit or miss kind of swells. You got to get them when you get them. And the other flip side of that too is high pressure will be dominant in the Gulf of Alaska this winter, and that will probably make for a lot of windy sessions. So whenever there is swell, it'll probably be blown out unless you can find some protected break to go surf it. All right, at least that's the forecast for now. But hey, we've been in kind of a warm regime for quite a while now. It's not surprising that we have to pay the price, so we're just going to have to buckle up and do it. This winter, I think that'll pretty much be it, because last winter really didn't do a whole lot either. This next coming winter, not so good. And then maybe we'll be in a better place. Now, we're not expecting we're going to jump right to El Niño or something like that, but we might move into a regime where things start warming up and looking a little bit better. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. Click the thumbs up. If you haven't subscribed, please subscribe. You'll get automatic notifications. If you don't want to do that, that's okay too. Go to stormsurf.com. We have links to the video here, and when we update it on the YouTube channel, we update it on our site. All the data that you've seen this evening is also available on the site. You can peruse through there, look at the wave models, look at buoys, all kinds of stuff. Dig as deep as you like. All right, so that's it for this week. Thank you for watching. We'll do it again next week. Same time, same channel. Thank you.